Hello and welcome to the data management course. The first unit we're looking at is counting, and the topic today is counting principles. So what is our goal today? I want you to be able to construct and use a tree diagram. I want you to be able to use the fundamental counting principle. And I want you to look at or be able to recognize indirect methods and when they are necessary or useful in solving problems. So this course is going to be quite a bit different in how traditional courses, trains of thought, and so on and so forth. Okay, so first method I want to demonstrate is called the tree diagram method. All right, so the example I'm going to use is Jenny is heading out for a night on the town. She has 3 pairs of shoes, 2 dresses, 5 shades of lipstick to choose from. How many options does she have for her night out? Okay, so basically she has what we would call 3 independent choices. So the way I would set it up, I'd be looking at it this way. So she's going to have shoes as one option. She's then going to have dresses. And finally, lipstick. All right, I'm sure I've got some girls in the class are saying, whoa, 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 whoa. If she picks a particular pair of shoes, there's no way she's going to pick a certain dress. And I'm like, okay, let's overlook some of the simple stuff here. So, Jenny, each of these represents a choice. So she has 3 pairs of shoes to pick from, and we don't have to be overly exact on this at this point. So she has 3 choices for her pairs of shoes. Next, if she picks her 3 shoes, one of those pairs, she then has 2 dresses to choose from. So that means that pair of shoes would have 2 choices. The next pair of shoes would have 2 choices. And the next pair of shoes would have 2 choices. And I don't have any idea why I picked 5 shades of lipstick because this is going to make this a little bit more challenging. But we'll see what we can do here. So move this a little bit. I'm going to have to get a little bit smaller. So this combination would have 1. Oops. Oh, what a mess. Okay. 1, 2, 3, 4, 5. The next one, 1, 2, 3, 4, 5. Look like this. And so on and so forth. Okay, so each of these would have 5 combinations. All right, 4, 5. So I'm just going to stem them off from there to make it look a little prettier. And you'll soon learn why. Tree diagrams, there's a time and place for them. This one, probably not the time and place. And then 1, 2, 3, 4, 5. So for her night out on the town, the question was, how many different options does she have when she leaves the house? Well, if we go through and count them here, we would have one group of 5, and they're all groups of 5. So we would have 1, 2, 3, 4, 5, 6 options. So therefore, 6 times each group has 5. So she's got 30 options. So therefore, Jenny has 30 different outfits. All right, all comes down to accessories. Any girl will tell you that. All comes down to the accessories. All right, so what it does is it allows us to look at each of the stages there. Now, obviously you've seen the immediate drawback to using tree diagrams. It becomes very cluttered. You have to really set up lots of empty space in order to use them properly. Are they important for us? Yeah, it's always a strategy to fall back on. So explain when or how tree diagrams can be used and provide some of your own examples. So you would use them when there are multiple independent choices. Okay, and independent simply means choice 1, keep it simple, choice number 1 does not affect choice 2. All right. So it doesn't matter what pair of shoes she was going to wear, she still had 2 dresses to pick from. So when, okay, I guess I can go down. When would you use them? When you use a tree diagram to graphically display, the possible outcomes for a series of decisions. All right, it is a nice visual display, if you give enough room, that people can follow and say, oh, I can see why there was so many options there. Okay, some examples of this. Choosing a car. If you ever go in and buy a car, you can choose the exterior color, interior color, options A, options B, a whole bunch of things. So you can do those calculations. Okay, obviously clothing choices. Okay, how about something as simple as making a sandwich? If you go to Subway, all right, or Mr. Sub, okay? Do you want it on brown or white? Do you want it toasted? Do you want Swiss, cheddar, mozzarella? Do you want lettuce? Yes or no? So every time you make a choice, you are increasing the possible outcomes. So the Subway or Mr. Sub tree diagram would be enormous, because every time you are asked an option, do you want tomato? Yes or no? There's 2 possible outcomes there, so you'd have to represent it in the tree diagram. All right? So let's talk about the fundamental counting principle. Fundamental counting principle simply says that for decisions where a series of multiple decisions, of multiple choices will be made, the number of outcomes can be calculated by m times n times p times ... where m, n, p ... are number of options. All right, so we need a couple of examples, and then we're going to go back and I'll show you how this works. So I'm going to start with the first example here. Barney is choosing an apartment. Okay, he's going off to university. If he has a choice of 2 types of flooring, so let's say carpet and hardwood, 3 different layouts, and his choice of any 10 floors for each model, how many apartment options are available for Barney? So we have, I'm going to set up similar to the tree diagram for now. So we have flooring, which you're going to find in this course too. It's kind of frustrating because I can't say this is the formula for everything, because these kind of they mutate, they take on different forms. So as best I can, I'm going to show you a way to organize your thoughts so that you can help express to me your final answer. So flooring, he had 2 choices. Layouts, he had 3 different choices, and he can get any of those possibilities on 10 different floors. Are they independent? If I pick carpeting for my flooring, does it affect my layout? The answer is no. So choice 1 doesn't affect choice 2. Similarly, I can get them on all floors, so it's independent. So that means that I just got to multiply them together, and I have 60 different options. So therefore, Barney would have 60 options. All right. Now let's take a step back. If you want to flip back to the previous one when we were talking about shoes, dresses, and lipstick, down in the corner here, wherever you have space, if I have shoes, dresses, and lipstick, I know she had 3 choices for shoes, she had 2 choices for dresses, and she had 5 shades of lipstick. And I know the girls are going to fight me on this, but if choice 1, the shoes, doesn't affect her dresses, it's independent, and dresses and lipstick is independent, 3 times 2 times 5 also gives you 30. All right, so that's using the fundamental counting principle. All right, so the last example at the bottom here, okay, car comes in 5 different colors. So this is the car thing. Okay, so we've got color, 3 different interior colors. So I'm just going to put interior, 3 different engines. And if you're thinking about it in terms of a tree diagram, this is getting kind of massive. 2 types of rims. So the fundamental counting principle, and the reason I'm using the headings, I'm giving you a way to organize your thoughts. Okay, and the radios. All right, so those are the options available. Car color, does it affect the interior color? Probably not. My interior colors don't affect my engines. My engine doesn't affect my rims. And the radios definitely have no effect. So in order to calculate this, then we're just going to use our straight multiplication. All right, so you go ahead and calculate that, and you get 360. So if you're going in to buy a car, okay, therefore you would have 360 options just to go in and buy a car. So you really have a lot of choice. You just maybe don't, because you've got certain tastes, that choice is narrowed down. But anyway, there you are. I believe I'm going to stop the video here, and then I'll finish the last 2 slides in the next video, just so I'm not rushing to jam everything in.